All right, ladies and gentlemen, today you're going to be spending class time working on this assignment called By the Numbers. In this assignment, you're going to be doing a little bit of math, which I know sounds scary, but the arithmetic on this is fairly simple. You just need to know the steps of how to make this work. So the big part of this today is doing something called the noon-sun angle. This is a calculation we did in class in the notes. But I know we've had a lot of people gone, a lot of people happen to be other places, and so I wanted to put this in a video so that everyone could do this and be successful on this today. In order to calculate a noon-sun angle, there are 5 steps to do this. The first thing you need to know is you need to know the date in question. The second thing you need to know is what latitude, that is, where are you on the Earth? The third thing you need to know is where on Earth is there a 90-degree noon-sun angle? And that's actually a tricky one. We'll get to that in a second. The fourth step that you need to do is you need to find the angle between 3 and 2. And then the last thing you do is you take 90 degrees minus your answer to number 4. So I'm going to walk you through how to get this started. Because it's kind of confusing at the beginning. And then you guys are going to take over from there and you're going to get this wrapped up today. That'll make a nice way to end the week. So here we go. So the first question says, refer to figure 2A, box 1, and calculate the noon sun angle for June 21st and December 21st at 50 degrees north, 0 degrees latitude, aka the equator, and 20 degrees south. And then we're going to look at which one has the greatest variation. Okay. So what I'm going to do down here, I'm going to make a little table to get this one organized. All right, so what we're supposed to do is we're looking at 3 locations. That is 50 degrees north, 0 degrees, 20 degrees south. And so I'm going to make me a little box that looks kind of like this. Okay, and this is going to be June 21st and December 21st, and then I'm going to call this the variation. All right, so we're going to calculate these things. So what I'm going to do, I'm going to call this, this first one, I'm going to call this box A up here. Okay, and so in box A, to answer this, we need to go through that 5-step process I showed you earlier. So here's how that works. The first step is we need to know when are we talking about? Well, okay, the date's June 21st. That's in the table. Second thing we need to know, what is the location? Okay, 50 degrees north. Okay, that's looking good. Step 3 is the hard part. We need to know where on Earth is the sun directly overhead. Okay, so here's the key for this. On June 21st, the sun is directly, this is called the summer solstice. And in our notes that I gave you, I told you that on the summer solstice, that means the northern hemisphere is tilted towards the sun, which means that the sun is directly above the Tropic of Cancer, 23.5 degrees north latitude. So that is the answer to the third part on that. Then on number 4, we need to know the angle between these two. That's how you get number 4. So we need to know how far is it from 50 degrees down to 23.5. Well, that's going to be 26. So I'd write it this way. 50 minus 23.5 equals 26.5 degrees. And then to find the noon sun angle, you calculate that by taking 90 minus this answer, 26.5, and that gives us 63.5, right? 63.5 degrees. So the answer in box A, the noon sun angle, is 63.5 degrees. Okay, so then I'm going to do the same thing, but I'm going to put this, I'm going to switch colors to make it clear what I'm doing here. Let's do box B here. So we're going to do the same location on a different day of the year. So what we're going to do here is, all right, we're saying 12/21, also known as winter solstice. All right, and winter solstice at 50 degrees north. And now we need to know where on Earth is the sun overhead on winter solstice. Well, the answer to that is the opposite tropic. That is the Tropic of Capricorn. So any solstice Winter solstice, it's that one. Summer solstice, it's 23.5 north. So those are answers you need to have to do this later. I'll get to there in a minute. Then step 4. It's a little bit of a trick on the old arithmetic here, because what we're going to do is we're going to treat this this degrees south, that's the southern hemisphere, we're going to treat that like a negative number. We're going to treat this north like a positive number. Up here, these were both positive numbers, effectively. They were both north. So all we had to do was subtracting 2 positive numbers gives us a positive number. So now what I'm going to do is I'm going to say this is a positive, this is a negative. So I'm going to take 50 minus a negative 23.5. Well, a negative, like subtracting a negative is a positive, right? Is adding. So this is going to equal 73.5 degrees. So that means this location is 73.5 degrees away from a 90-degree noon sun angle. So 90 minus 73.5 gives us 16.5. All right, so the answer to B is going to be 16.5 degrees. Now, to answer the question here for the variation, how much does the noon sun angle vary here? Right, we need to take 63.5 minus the 16.5, and that gives us a variation of, I'll do that in, purple, I guess. That gives us a variation of 47 degrees. Okay, so what you are to do is you are to fill in the rest of these boxes by doing the same thing, except you're starting with, we're going to have different, we're going to use the same dates, A and B like this, but our latitudes are going to change. That's going to change your calculations. So this 0 degrees is going to be that 50-degree number, and then it's going to be that 50-degree number. And then 20 degrees south is going to go here, and then 20 degrees south is going to go here. So we got to work on it that way. All right. So then that's how you do question number 1. So we're going to find those noon sun angles and then find the variation by taking the difference, okay? The second question right here, the second question, it says, determine the length of daylight and darkness. You can just look up table 2.1 in the text. So honestly, it's probably even faster to Google that. Daylight and darkness by latitude is fairly easy to do. So you can Google that one or look that up in the text in Google Classroom. Okay, number 3, calculate the noon sun angle at your location for the equinoxes and the solstices. Okay, so we're going back to that noon sun angle, and now we're saying our location, remember, southern Kansas, like Altamont, is about 37.5 degrees, something like that. 37.5 degrees north latitude, that is our location. The equinoxes, that is March and September 21st. The solstices are what we did on problem 1, 12/21, okay? So the key here is that these dates, right, this one coded to 23.5 degrees north, this one coded to 23.5 degrees south. The trick here is that both of these, the equinoxes, the 90-degree angle happens at 0 degrees latitude, the equator. Okay, so that's the number that you use for the third part of the 5-step process when you're calculating the noon sun angle. So you're going to do that for our location. If you're clever, you might know that we've actually already done these two in our notes. Did you write that down? I hope so. Okay. Number 5. Oh, ignore this picture. That was not supposed to be in there. I meant to take that out and I forgot to. Sorry. I also took out, this went with number 4 and I took out number 4. Okay, so number 5 says the accompanying analemma is a graph used to determine latitude where the overhead noon sun angle is located for any date. Okay, so what we're supposed to do here is take one of these dates. I'm going to start with March 21st and figure out where is the sun directly overhead. So what you do, and I apologize, the digital version of this did not come out very good. You find March, which is right here. That says March, okay? And you're looking at the dates. Okay, so it's going like this, right? And so March 21st is right here. And March 21st, you go over, and it's at 0 degrees latitude. So, interestingly, September 21st is on the same line. So that is why. So the answer is 0 for March 21st. All right, so you're going to do the same thing for June 5th and December 10th. So you're going to have to find, so June, so there's December and June is up here. You have to figure out what angles. You're going to have to find some angle that goes over there, goes over this way, and some angle in December that goes over this way. So you're going to need to write down the answers for number 5. Then for number 6, we're going to do one more time this noon sun angle. Only now what we're going to do is this analemma effectively gives us the answer to the third step. That's what you're doing. So that's the answer to number 3 in our 5-step process. So you're going to try this on our location. All right, so again, we're going to use 37.5 degrees north latitude on these dates. And you're going to use the analemma to get where on Earth is the 90-degree angle. So the answer to number 3 on that 5-step process comes from that graph down there. Okay, so that is your assignment for today. You guys totally can do this. Good luck, and we'll see you on Monday.